Okay, guys, so we're looking at problem number 10 from the homework assignment here before we get started. So when we look at these two angles, 118 degrees, which is going to be this angle right here, and 8x plus 6, which is this angle right here, well, if they are corresponding angles, they would be congruent. Well, are these two corresponding angles? Well, no, they're not in the same spot. Are they alternate interior or alternate exterior? Well, they are alternate, yes. Interior mean they both be between the two parallel lines. Well, they're not. And exterior mean would be that they're both outside. Well, they're not either one of those. So they're not going to be congruent. But I do know 118 and this angle here would be congruent because they are corresponding. So it means these two angles here are going to add together to be 180. So we can say that 8x plus 6, we could, and then subtract 6 and solve it from there. Yeah, you would get the same answer. 118 plus 6 is going to be 124. Minus 124 from both sides, because 124 minus 124 would be 0. So we're left with 8x is equal to 56. And at this point here, we can divide both sides by 8, which tells us x is equal to 7. Welcome back. Any other questions on the homework? Okay. Yeah. All right. If there's no other questions on the assignment, let's go on and look at today's. Now, what we talked about yesterday with corresponding alternate interior, alternate exterior, or consecutive angles was that they were congruent. So our corresponding angles for this here would be angle 1 is going to be congruent to angle 5, because 1 and 5 correspond to each other, so they would be corresponding angles. We also have what? That 2 is going to be congruent to 6. We also have what? 3 is going to be congruent to 7, and 4 is going to be congruent to 8. Because those are corresponding angles. They're in the same location. They correspond to each other. Yes. Huh? Or they're in the same spot, yeah. Now, our alternate interior angles that we covered yesterday for this setup here would be angles what? So 3 would be congruent to 6, and 4 would be congruent to 5, because they're between the two lines, they're inside the interior, and they're on opposite sides of the transversal. Our alternate exterior would be angle 1 is congruent to angle, and 2 is going to be congruent to angle. Now our consecutive angles would be angle 3 and 5, and 4 and 6. Now our consecutive angles, our consecutive interior angles, aren't congruent. They are supplementary. They add together to be 180. Consecutive angles, so they're on the same side of the transversal and between the two lines. Now we don't necessarily consider consecutive exterior angles, so 1 and 7 and 2 and 8 in this, but they do have the same property as the consecutive interior. They're going to be supplementary. They're going to add together to be 180. But this here is what we covered yesterday. Okay. You ready for the next slide? So our first theorem of the day is these corresponding angles converse, the corresponding angle converse. It states if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. Because what we had yesterday was if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So this here is the converse because we're not starting with the fact that the lines are parallel. We're starting with the fact that the corresponding angles are congruent, which means the lines are parallel. We flip the hypothesis and conclusion. So if we can prove that the two corresponding angles are congruent, then we can say the lines are parallel to each other. So our first problem that we're looking at is asking us what values of x makes m parallel to n. What value of x is going to make these lines parallel to each other? Well, according to our corresponding angle converse, well, if these two angles, which are corresponding angles, are congruent to each other, then the lines are parallel. So really all I need to do is show that 3x plus 5 is equal to 65, because if that value of x holds true, that these are equal, then the lines will be parallel. So now we just need to solve for the value of x. Subtract 5 from both sides. So after we subtract 5 from both sides, 65 minus 5 would be 60. 5 minus 5 will cancel out. Now we do need to divide both sides by 3. Because 3 divided by 3 would be 1, leaving us with just x. And 60 divided by 3 is. So the value of x that will make these two lines parallel is 20. And that's it. That's what we got to do with this here. Any questions on this here? Are you ready for the next one? Find the value of x that makes these two lines parallel. Is 72 degrees and 4 times x plus 5, are they corresponding angles? They're both outside, yes? So for them to be corresponding, they need to be in the same place, yes? So 72 is to the right and above. The 4 times x plus 5 is to the right but below. So they're not corresponding. But the one that would be corresponding to 72 would be this one right here, yes? Because if it is 72 degrees, then these would be parallel. Also, if this is 72, these two here should add together to be what? 180. They should be supplementary. So what we can say is that 4 times x plus 5 plus 72 is equal to. Yes, we would distribute the 4 first. So we're going to multiply the x and 5 by 4. Because 4 times x would be 4x. 4 times 5 is 20. And then we have our plus 72. Now we can combine our like terms, 20 and 72. 20 plus 72 is, and this here is equal to 180. Now we do need to get the x by itself, so the first thing we can do is subtract 92 from both sides, which will tell us that 4x is equal to 88. At this point here we can divide both sides by 4, which tells us x is equal to 22.
If those two, 72 and that 4 x plus 5,
Uh-huh.
80, why couldn't you take that 72 minus 180?
Yeah, that's fine.
Okay.
What did you get for 180 minus 72?
180 minus 72, 8.
Because 180 minus 72 because that would be 108. Because we can't do that, so it'd be, because we have to move the 1 over. 7 and 7, 0, and we drop the 1 down. Yeah. So setting 4 times x plus 5 to 108 would also work.
I borrowed about 1.
Yeah. Any other questions on this here? Let's put the Chromebook away. Let's look at this one here. Is there enough information to say that the two lines are parallel? So far, the only theorem that we know for sure about proving the two lines are parallel is our corresponding angle theorem, yes? So we know that that angle is 75. Well, this is 105, yes? Two angles that make a straight line add together to be 180. So even if these aren't parallel, if this is 105, I can take 180 and subtract 105 from it, 75. So this angle here is, well, wait a minute, 75 and that 75 are corresponding angles, aren't they? So can we say that these are parallel? Yes, because of our corresponding angle theorem. Now we could have gone the other direction and said 180 minus 75, which would be 105, which would be this angle down here, and the 105s would be corresponding. So and we can say this because of our corresponding angle converse would be our reasoning or our explanation. Questions on any of this here? Okay. We're not going to worry about that. Now, this here is already in your note sheet. The alternate interior angle converse, the alternate exterior angle converse, the corresponding interior angle converse. All of these are saying if two lines cut by a transversal so that either the alternate interior angles are congruent, the alternate exterior angles are congruent, or the consecutive interior angles are supplementary, then the two lines are parallel. As if our alternate interior angles are congruent, alternate exterior angles are congruent, or the consecutive interior angles are supplementary, then we can say that the two lines are parallel to each other. Now we're going to use, because out of all of them, out of all the properties we've had, we've only really said that the corresponding angle converse is true. Now we can use that to actually show that the alternate interior angle converse is true as well. Now with any of this here, we always start with the given. Well, the given is that angle 4 is congruent to angle 5. And our last one is going to be that line G is parallel to line H. G is parallel to H. So we're told that 4 is congruent to 5. Well, I also do know that 1 is congruent to 4 because they are vertical angles. Yep. Well, we said 4 is congruent to 5 and 1 is congruent to 4. So what can we say? Angle 1 is congruent to angle 5 because of our transitive property of congruency. 1 is congruent to 4, 4 is congruent to 1, so 1 has to be congruent to 5. Well, 1 and 5 are corresponding angles, aren't they? So we can say the lines are parallel by our corresponding angle converse. So really what this has shown us is that the alternate interior angle converse works as well as the corresponding angle converse. Any questions on this here? You're good. It's just in chapter 2.6. They just decided to number them. Okay. Okay. All right. Now we do have this proof here in this one, but we'll go on and move on because I'm not going to ask you to do proofs anymore. We will do proofs throughout the year, especially when we introduce a new concept or we're trying to show something is true. I will go on and prove it. We'll prove it together in class, and then we will accept it as fact. Now the next theorem we have is this one here, the transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. Really, we're saying if P is parallel to Q, then Q is parallel to R, well, then P is parallel to R. Because two lines are parallel, I'm not coming any closer or going any farther away. Yep, our two lines. Yep. So these two are parallel and these two are parallel, so Q is parallel to R. Questions on this here? What's interesting is the parallel symbol is in parallel. Goes two lines. So let's look at this here. Find the measure of angle 8. Well, we know that P is parallel to Q, and Q is parallel to R, so P is also parallel to R. So they will be matching up, and we can use our alternate interior, alternate exterior, corresponding, or consecutive interior angles theorems. Now, 115 and the measure of angle 8 are on the same side of the transversal, yes? So could they be alternate interior or alternate exterior? Well, alternate interior or alternate exterior means they've got to be on opposite sides of the transversal, either both inside or both outside. Well, if they're on the same side, well, we can't use either one. So are they corresponding? No. Well, 115 and this one here would be corresponding angles, yes? Because they're both on the right side of the transversal and above the line. Wait a minute, that means 115 and 8 do what? Let's put the Chromebook away. Thank you. They add together to be 180. So we'd have 180 minus. So the measure of angle 8 would be 65 degrees.
Wait, so what were you talking about? 15
Because 115 and 8, are they corresponding angles? No, so are they alternate interior? Are they alternate exterior? No. So that means they can't be congruent, because if they're one of those three, then they would be congruent. So we have to find another method to see, well, we can find it. Well, that means they had to go to be 180. Because what we've seen with most of these here with corresponding, with our two lines cut by a transversal that are parallel, they're either going to be congruent or add together to be 180. It's going to be one or the other. So here they were supplementary. Questions on this here?
That little arrow.
Mm-hmm.
Like, what is that? Yeah.
Parallel. So we're showing that the lines are parallel to each other. Last problem of the day. The United States flag has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why this top stripe is parallel to the bottom. Well, we know that S1 is parallel to S2. Well, S2 is parallel to S3. S3 is parallel to S4 because it's saying that it's parallel to the stripe immediately below it. Well, we can continue on like this until we say really S12 is parallel to S. Therefore, S1 is parallel to S13. And we're really just repeatedly using our transitive property of parallel lines because one's going to be congruent. It's just an arrow. Mm-hmm. It's also, in mathematics, we use it as therefore. Since all of these are parallel, therefore, by our transitive property of parallel lines, we can say that the top line is parallel to the bottom line. Well, each stripe is parallel to the stripe immediately below it. So 1 is parallel to 2. 2 is parallel to 3. 3 is parallel to 4. 4 to 5. 5 to 6. 6 to 7. 7 to 8. 8 to 9. 9 to 10. 10 to 11. 11 to 12. 12 to 13. Also, by our transitive property of parallel lines, if two lines are parallel to the same line, then they are parallel to each other. Yeah, since they are parallel, since all of these are parallel to each other, it means that these have to be parallel to each other. Okay. Questions on this here? That is it. So your homework is on page 130, 3 through 8, 11 through 16, 21, and 20.